Yeah, 3 hosts.
Okay, so let's just review a little bit. Each of these structures, what do you know when you get the final structure? What are some things you can look at to know that you got probably a good structure? So look at what you have on paper, see what's common in everyone, and tell me what you guys see that is probably consistent in all of them. One thing, it's every single one, 100%, except for hydrogen, has this characteristic. What's it have to have? 8 electrons. Right? So there'd be four pairs, except for hydrogen, and it has, they call it a duet rule. I don't know. One has an octet rule, but basically know that hydrogen can only have the 2. Okay? So that's consistent every single time. You draw a molecule, every single symbol within that Lewis dot structure has to have 8. Okay? Can't have 7, can't have 9, can't have 6. It's got to have 8 to be right. If it doesn't have 8, then you guys see what you're doing to make that correct. Another thing is I would encourage you from now on when you write carbon to write 4 separate dots. Beforehand you guys are probably writing carbon like this. What I want you to do is change that up. And I want you now to write it like these, and I can't really explain why it's different than those other ones that have to show pairs, but trust me, you'll want to do that so that these structures today, when you do them, to make sense. When you write these out, also you're going to find something else consistent all the time. You guys see these 3 unshared pairs? We call them lone pairs or unshared pairs. On that structure, when you finally write the structure, does fluorine on the second one, I'll give the first one real quick. That one was really easy. So it should look like this, and then you were supposed to make it simple by drawing the lines. So those are the 2 drawings for that one, right? So for this one, you had carbon in the middle, and you would have your 2 fluorines around the outside. Doesn't matter where they're positioned as long as they're connecting to the center atom at some point. Doesn't matter where they're at, okay guys? Because we can rotate this through space and it can take on different looks if we have a 3-dimensional look. Okay. So then this looks like this when we go ahead and just draw the lines. So that's what you should have for the second one. So what I want you to look is, I want you to look at something that's always going to be consistent all the time. Look at fluorine before. Look at fluorine afterwards. Okay? So what do you see common in the 2? What's one thing you see common? Yep, it still has the 3 unshared pairs. That's common. You're never going to show fluorine without its 3 unshared pairs. Does that make sense? So this, what it looks like, the picture, what it looks like before, must look like afterwards when you look at the lone pairs. They have to. Every single drawing, 100%, should look the same before and afterwards. Okay, of the ones we're doing. Now, in AP Chem, here, starting today and tomorrow, that's not always the case. So there are exceptions, and they start getting into those exceptions, which makes it a little bit tougher. Look at hydrogen. How many unshared pairs does it have to begin with? 0. Right? There's no pairs on it. So how many does it have here? 0 unshared pairs. Okay? Carbon, now from now on when we write the carbon, here there's no unshared pairs. What about that carbon? Is there unshared pairs on that carbon? No. Everything's shared. Okay, so that's why we're going to write it like this. Does that make sense? So 2 things you want to always have consistent 100% of the time. I hope I'm right on this, because if I'm wrong, I'm going to eat my words. you're always going to have same unshared pairs. They're going to be the same. So that's why you draw the pictures beforehand. I know it's a little bit extra work. Draw those pictures beforehand, draw them afterwards, and they should match up. Okay? All right, we'll do... you guys started out real good on these, and then I don't know if you didn't do them in class, and so that kind of... You didn't do them outside of class, but this would be the one. And then just see if those rules work for this. See if it should be 100% of the time. It's not like that one saying that says 60% of the time it works every time. You guys know what movie that's from, you know? You know? Anchorman? Did you guys ever watch Anchorman? No, okay. That doesn't make sense, right? 60% of the time it works every time. So, you guys are a tough crowd this morning. Tough, tough, tough. Is that what you have for the second one? Okay, this is really messy. I mean, it's hard to kind of see what's going on when you got all those dots going on. But you can look at the individual ones and look at bromine. Does it have 3 before and after? Yeah. Iodine, does it have 3 before and after? Yeah. Nitrogen, does it have 1 before and 1 after? Yeah. Okay, now, I'm going to write these pairs of dots above here around the central atom when I have a chance. And I'd like you guys to do the same. Because what it does is going to help us next week, come Monday and Tuesday, where we're going to start putting these compounds together. Okay? Now, this NH4, when we count them up, beforehand we have an odd number. We have 9. The plus means you take one of those 9 away. So you have 8. So the final structure should look like this. Okay. So I'm eating my words already, right? Look at this structure. Does it have an unshared pair? Nitrogen has an unshared pair here, but it doesn't here, right? So what happened? One of these electrons were taken away, right? So really, in a way, it is, because we take one of those electrons away from nitrogen and it doesn't have any unshared pair. So when you get to the pluses and minuses, they don't really hold true all the time. This last one you can have written a couple different ways. I want you to tell me what you think is the best way to write it, and then we'll see. I'm going to write both ways that you could have had. All right? And then we'll look at which way was maybe the better way in which to write it. Here's one way. Now, the negative 1 means we added 1 electron. So I think it's 26. Is it right? Is that right?
Yeah.
Okay, so 26. So here's one way you can write it. So, okay? And here's another way that you could get away with writing it. In AP Chemistry, we have this thing, we find formal charges, and we're not going to do it in here. But formal charges kind of allow us to kind of see what it looked like before and afterwards and see if they fit the best. Okay? So chlorine being in the middle, you wouldn't think that would be in the middle because it doesn't need the most to be in the middle. But since a lot of you figured that there was one of them, and we have a trend a lot of times where the one, if we have one of them, it kind of goes in the middle because that's kind of been the trend. So this oxygen has 3 unshared pairs where the original one had 2. 3, 2, 3, 2. Chlorine had 1, and it has 3 here. Where on this one, oxygen has 3, 3 here. 1, chlorine has 3, and chlorine has 3 here. So this might be a better structure because this is the one that holds true to what it will look like before and afterwards. But either way would be okay with me. There's one way that's best, and we're not going to go through and probably have that come up very often if you follow the rules.
Carly, can you go back to the next one?
Yep, I can go to the previous one. Now, what we're going to do today is we're going to do a structure, and then you're going to go through step 5, and when you get to step 5, things aren't going to work out so good. And so I'm going to give you a formula, and then we're going to practice you going through those steps, just reviewing them, and then once we get to step 5, something happens that didn't happen in these 5 examples. Okay. So what I'd like you to do is write this formula down right here. And go through and draw the dot structure all the way through step 5. So, step 1, draw them out, count the electrons. Should be an even number. Step 2, determine which one should be center between N, S, and Br. Step 3, pair up the shared pairs between the central atom and the branched atoms. Number 4, branched atoms get all the electrons after that point until you run out. If, by chance, you don't run out and you got extra left over, step 5 says you need to put them off the center. So 1, draw them out, count them. Step 2, find out which center. Step 3, put it in center. Do your shared pairs. Step 4, all the branched atoms get all the rest of the pairs to get 8. Step 5, if they're left over, you can go off the middle. The middle gets the electrons last. Don't ever give them middle electrons until all the other ones have their octet of electrons. Okay, so do those 5 steps, and then we'll kind of see what our final product looks like. When we're done writing it out, nitrogen doesn't fulfill the octet rule, and it has to have 8. That's a solid rule. Okay? Now, I want you to look at bromine. I've got bromine kind of messed up because I got happy with my electrons. So look at bromine. There's a spot right here that's missing, right? On sulfur, there's 2 spots missing to get 8. And nitrogen has 3 spots that are missing. Okay? Does bromine look the same before and afterwards when it comes to lone pairs? It does, doesn't it? It's got free and free. Bromine's good. Don't change anything on bromine. Look at sulfur. How many does it have here? 2. How many does it have here? 3. So that doesn't look good. Okay, nitrogen. Nitrogen looks fine, but it doesn't have 8. It has its 1, but it doesn't have 8. So wherever you have multiple spots, that means you can have multiple bonds. That means you can share more than 2 electrons between 2 atoms. Nitrogen has 3 spots. Actually, nitrogen possibly could share 3 spots between it and another atom if possible. So this is what you have to recognize, is that sulfur doesn't have the same before and after. Nitrogen does. And so what we're going to do is we're going to get nitrogen, its 8, by taking a pair that shouldn't be there on the original and then putting it in between. So what we're going to do, when we recognize we don't have 8 off the center, we're going to erase a pair, and we're going to place that pair here. Now, sulfur looks like the same thing now, before and afterwards. Okay, nitrogen was okay, bromine's okay. Now the question is, when you look at bromine, it has 8. When you look at nitrogen, does it have 8 now? You
Yes.
count these two as 4. So 2, 4, 6, 8. And this sulfur has 8. 2, 4, 6, 8. So now everything looks the same when you look at lone pairs, before and afterwards. That looks good. So then when we draw, this is where we end up with our double bonds coming in. So there'll be a double bond there. Okay? Questions? This is before I did my double bond. Okay, this is what it looked like. Gotta make sure I got the right element in there. Okay, so this is what it looked like before, and it doesn't work this way. So what I've decided to do to match up my lone pairs, I get rid of one of these and put them in between. And so what happens between sulfur and nitrogen, see, sulfur can share 2 places. See, they're sharing 2 places, these 2 places. And it's sharing with 2 places of nitrogen here. So these 2 really are hooking together if we would take a look at it. There's your double bond. And then on the outside here, we have bromine, and then that's your other bond, that single bond that takes place. Okay? Alright, so I'm going to give you one, and I want to see if you can handle doing this next one. So carbon, we're going to go C, F, P. CFP. See if you guys can do that one. CFP. 16 electrons, and then we end up with that after step 5, right? Then you look at the beginning. Does fluorine okay, the way it's written? Fluorine's okay. Okay, so basically, whatever you do with fluorine, chlorine, bromine, and iodine, which is a halogen group, you only can have one single bond with it, so you always leave fluorine. Fluorine cannot contribute any extra electrons. Here's the problem with fluorine. It is so hungry for electrons, it's not going to give any up. It has a high affinity for electrons. Some of these other elements, they're going to. So then you look at phosphorus. Look at what's wrong. It has 3 lone pairs, and then there it has 1. So what are we going to have to do with 2 of these lone pairs? You got to share them. You got to put them in between. So you're going to take this one, and it doesn't matter which ones you pick, guys. Still, the results are going to be the same. And then you put them in between. Okay, now does phosphorus have the same lone pair? Does. Does carbon have any lone pairs? No. That's what we want. Everything looks the same before and afterwards. So, see, triple bond P, bond F, that's what your line structure is going to look like. Okay? So you have to determine which ones can be borrowed. And you do that 2 ways. You can look here and realize, see, phosphorus can borrow 3 places, and carbon can borrow or share between it and phosphorus 3 places. So that's what happens. And then your unshared, your lone pair should work out right too. So you guys have the opportunity to work on and practice some of these. So you're going to do 4 of these for Monday. You should be able to get them done. NHSE before you go. SICLAS P Cl2 H and CASBR. Okay, so do those in order and see what you guys kind of come up with for your answers to those. Okay? Draw both the dots and the lines.